Okay, now we will be discussing the Module 13 of SRWE course, which is the WLAN configuration. Okay, the objective of this module is implement a WLAN using a wireless router and wireless LAN controller. We have here four topics for this module. We have the remote site WLAN configuration. So we need to configure a WLAN to support a remote site. Configure a basic WLAN on the wireless LAN controller. So we use a wireless LAN controller to use the management interface and WPA2 PSK authentication. So also need to configure WPA2 enterprise WLAN on the WLC, and also troubleshoot some WLAN issues. Okay, for remote site WLAN configuration, we have so just need to skip this video because the wireless router, this router, let's see. Okay. So remote workers, small branch offices, and home networks often use a small office and a home router. So these routers are sometimes called integrated router because they typically include a switch for white lines and a port for internet connection. So sometimes labeled one. So one of these ports is connected to the internet. Can be used to connect to internet. Then wireless components for wireless client access. Have So the next figure shows a topology depicting the physical connection of a wired laptop to the wireless router, so which is then connected to a cable or DSL modem for internet connectivity. Okay. So we have here the client connected to the wireless router, so using a wired media. And then this wireless router is connected to the broadband modem. It's also wired connection. And then this broadband modem is now connected to the internet. So these wireless router typically provide WLAN security. So DHCP services. This is for the IP addressing, the integrated NAT or name address translation. So it is used for translating the private IP address into internet routable address. The quality of service as well as variety of other features. The feature set will vary based on the router model. So log into the wireless router. So we just need to type in the IP address of our home router and then on the web browser. Then upon entering the IP address, some authorization will appear or pop up. So you just need to type in the username. So username and password. So commonly the admin is used as a username and password in new routers. Okay. So basic network setups. So basic network setup includes the following steps. So first is the login. So first one is log into the router from a web browser. So this is the GUI. So after accessing the IP address, okay, the GUI will have tabs or menus to help you navigate through various router configuration tasks. So it is often necessary to save the settings, change in one window before proceeding to another window. So at this point, it is best practice to make changes to the default settings. So second step is change the default administrative password. So just need to type in our new password here in the administration tab. So after changing the password, so the wireless router requests authorization again. So you just need to enter the username and new password here. You also need to change the default DHCP IPv4 address. So change the default router IPv4 address. It's best practice to use private IPv4 addressing inside your network. So the IPv4 address 10.10.10.1 is used in the example, but it could be any private IPv4 address you choose. Okay, so let's see. So private IP address. So I have three private IP address ranges. So I have here for 24-bit block. So it starts with this one. It is 8 bits. Also have the 172. This range, and the most common, the 192.168. Okay. Next is renew the IP address. So when you click save, you will temporarily lose access to the wireless router. So you just need to open the command prompt to renew our IP addresses with the ipconfig /renew command. So it is used to renew our IP address. So log into the router with the new IP address. So just need to access our router with our new IP address. So basic wireless setup. So there are 6 steps. The first one is view the WLAN defaults. So out the box, a wireless router provides wireless access to devices using default wireless network name and password. So network name is called the SSID, or service set identifier. So locate the basic wireless settings for your router to change these defaults as shown in the below. So we have here in the wireless tab, and then basic wireless settings. We have the default configuration here for 2.4 GHz, for 5 GHz. So we broadcast the SSID. Network name is set to default. So the standard channel we have channel 1. Okay. So first we need to change the network mode. So some wireless routers allow you to select which standard to implement. So the example shows that legacy has been selected. So this means wireless devices connecting to the wireless router can have variety of wireless NICs installed. So this means wireless devices connecting to the wireless router can have varieties of wireless NICs installed. So today's wireless routers configured for legacy or mixed mode most likely support these standards. As for NICs, we have the A11A, 11N, and 11AC. And we configured that for legacy. So we just need to configure the SSID name. So the network name or SSID is set to default. So we just need to change this. In this example, we change the default name to OfficeNet. Next is we need to configure the channel. So we need to set the standard channel wherein channel is not other devices can interfere with. So in this example, we choose the channel 6. So configure the security mode. So for the WPA personnel, we use the AES encryption. So AES is used commonly for WPA2, but I think we can also use the AES with the WPA. Okay. So we also need to configure the passphrase. Here, the passphrase is literally the password that the wireless clients must know to connect to the wireless router or access points. So configure a wireless mesh network. Is this okay? So in a small office or home network, one wireless router may suffice to provide wireless access to all the clients. However, if you want to extend the range beyond approximately 45 to 90 meters outdoors, you can add wireless access points. So shown in the wireless mesh network in the figure, two access points are configured with the same WLAN settings from our previous example. Notice that the channel selected 1 and 11 so that the access points do not interfere with channel 6 configured previously on the wireless router. Okay, so is the topology here. We have the two access points. So it said that the access points are configured with the channel 1 and 11. So channel 1, 6, and 11 are the channels that don't interfere with each other. We also have configured the authentication methods. So NAT for IPv4. So NAT is okay on the wireless router. If we look for a page like the status page shown in the figure, you will find the IPv4 addressing information that the router uses to send data on the internet from the status page. So notice that the IPv4 address is 209.165.201.11. It's different network than the 10.10.10.1 address assigned to the router's LAN interface. So all devices in the router's LAN will get assigned net address with the 10.10.10 prefix. Okay, so NAT is the network. This is the NAT. So network address translation. So it just converts private IPv4 address to internet routable IPv4 address. So this is our internet IP address. Okay, this is the it's a public address, routable in internet. So the one that we configured, this address is the private IP address. It is the address used for our devices connected to the wireless router. Also have the quality of service. So it is used to, let's see. Okay, this is used for the prioritizing some of the types of traffic such as voice and video. Okay. Port forwarding, what is this? So wireless routers typically block TCP and UDP ports to prevent unauthorized access in and out of the LAN. So, however, there are situations when specific ports must be opened so that certain programs and applications can communicate with devices on different networks. Okay. Port forwarding is a rule-based method of directing traffic between devices on separate networks. Okay. This is just for port forwarding for us to for us to communicate with devices on different networks. Okay, use that. So also have the packet tracer. So this we will be doing this later on. Yes. Next is configure a basic WLAN on the WLC. Okay, we now use the wireless LAN controller. So WLC topology, we have here the access point, the laptop connected wirelessly to the access points. The access point, then it is connected to switch. We also use the wireless LAN controller here to manage the AP and configure it. Also have the PCB and another PC here, so it's configured on the another network or other network. So it serves as a radius and SNMP server. Okay. Also have the router for routing traffics from this local network to other networks. So we have your addressing table for these devices. First one is we need to log into the wireless LAN controller. So it's the same with accessing the wireless router. So you just need to access it through the web browser. So we use the IP address of the WLC, and also the authentication is message pops up, and we need to type in the username and password. Have the network summary page. It's dashboard that provides a quick overview of the number of configured wireless networks, access points, and active clients. So we have here the network summary, wireless networks, the access points. We have one, but we don't have the wireless local area network. The active clients we don't have also, rogue APs and clients, and interferes. So we have no interferes nearby. You can also view the AP information here in the access points tab. Okay. So this is just pinging the access point. Okay. For us to verify the wired interface on the switch. So for advanced settings, so most wireless LAN controller will come with some basic settings and menus that users can quickly access to implement a variety of common configurations. So however, as network administrator, you will typically access the advanced settings. So you just need to click the advanced here. It is located here. So advanced summary page. So from here you can access all the features of WLAN. Okay. Monitor, WLAN controller. So all of these tabs. So for this monitor, we also have the summary, access points, Cisco Clean Air. Okay. Nandiyan si Mama. Alex, tawag ka. For configuration of a wireless local area network. So first one is we need to create the WLAN. So this is just a configuration for a basic wireless local area network. So the next one will be enterprise WLAN. Okay. So first one is we need to create the WLAN. So shown here. I think we need to create the new WLAN. So there is a new settings there. Just need to click new. So we set the type to wireless local area network, also the SSID and the ID of one. So in this example we use the wireless LAN as the SSID and profile name. So next one is apply enable the WLAN. So we just need to check this checkbox for the enabled status. Okay. Select the interface. So just need to create select the interface. So it's the user WLAN. So I think the interface is out of the scope here. We also need to secure the WLAN. So we use WLAN. So in this example, we have the AES as encryption. We also use DPSK. We disable the 802.1x authentication because it's used for enterprise. Also entered our password. This is for a password. Let's see. Alright, this is for the password. So also verify the WLAN is operational. So you can see we now have the WLAN configured. So monitor the WLAN. So click the monitor tab, tap access. You can now see our wireless local area network. So we have the profile name, wireless LAN. View wireless clients details. So on this clients tab here on the left side, you can now see the MAC address of the client, the given IP address, the name of the access points it connected to, and then some of the details of the access points. We also have the packet tracer figure. So all these packet tracers on module 13 are done with this on the bridging course, but we will do it again. Okay, now is configure a WPA2 enterprise WLAN on the WLC. Okay, so SNMP and reuse. So we use the SNMP to send the SNMP log messages from the WLC to PCA. So it's for us. So here in the topology, we configure the PCA as Radius SNMP server. So the SNMP will monitor the traffics associated with the wireless local area networks configured. And then for the radius, it is used for the authentication of wireless clients. So when the wireless clients sent the username and password to the WLC, now the WLC will send this to the PCA to authenticate it. Okay, to configure SNMP server information. So first one is, so from the wireless LAN controller, we click the management, then click SNMP, trap receivers. So we don't have a SNMP trap receiver, so we create new one. Then after creating, we will set the community name, the IP address. So this is the IP address of the PCA, which is the SNMP server. Then enabled, then click apply. Now we need to configure the radius server information. So from the security, we click the radius and authentication and click new. So from there, we need to type in the server IP address, which is the PCA, the shared secret, and confirm the shared secret. So this is the secret or the password for or key of the WLC and the server. Okay. So we can verify it. The configure radius authentication servers. So you can see we now have one here. Topology with VLAN addressing. So each WLAN configured on the wireless LAN controller needs its own virtual interface. So the WLC has 5 physical ports for data traffic. So each physical port can be configured to support multiple WLANs, each on its own virtual interface. Physical ports can also be aggregated or joined to create high bandwidth links. Okay, the network administrator has decided that the new WLAN will use interface VLAN 5 and network 192.168.5.0. Router 1 already has the sub-interface configured and active for VLAN 5. Okay, so shown in the topology and show IP interface. So we now have the sub-interface configured in the R1 to carry the VLAN 5 traffic to other networks. So we just need to create the VLAN from the WLC. Okay. Interface from the router 1.5 192.168.5.254. What is this? Let's see. Don't have the IP address in here. 201. I think this is for the management. And then this is for the user traffic. So for configuring the interface, just need to create the new interface from the controller, select the interface from the left side and click new. So we are using creating an interface for VLAN. So we already created a VLAN. Okay, we are creating a VLAN. So configure the VLAN name and ID. Just need to type in the interface name, and then the VLAN ID, which is 5. Okay. Next is configure the ports and interface address. Port number 1, so I think this is the physical port number, so the port 1 in the wireless LAN controller. And then also type in the interface address, so 192.168.5.254, and that must end the gateway, which is the router's interface, 5.1. Okay. Sub interface 5.254. Why it's different? Okay. Configure the DHCP server address. Just so the router is our DHCP server, so we just enter the IP address of the router and apply and confirm. Then also to verify the interfaces. So in the list of interfaces here, you can see the VLAN 5. Okay. So now for configure a DHCP scope, so it's the same with DHCP pool. So but DHCP scope is used for providing IP address in the I think this is used for management devices or IP address for access points, something like that. So create a new DHCP scope. So this is the first step. So information including a pool of addresses to assign to DHCP clients. Then the server information, list times, and more. So you just need to click the internal from the controller, so internal DHCP server and DHCP scope, and we just need to create new DHCP scope. Next is need to name the DHCP scope. Next one is verify it. So as you can see, we now have the wireless management scope, but we don't have the address pool, so we need to configure it. Then we type in the start address and end address, so it's 2.40 to 249. So this is the starting address, so the first device that will connect to our network, to our wireless local area network, will be given with this address. Okay, we also have the network, which is 200.0, and then the subnet mask. We also need to configure the default router. Also verify the enabled DHCP scope. So now the address pool is now configured. Configure a WPA2 enterprise WLAN. So we now have 6 steps again. The first one is we need to create a new WLAN. Okay. So from the WLANs, create new, and configure the WLAN name and SSID. So you just need to type in the profile name and the SSID, which is the company name. So any name, but in this example we use the company name. We also need to set up the ID. So enable the WLAN for VLAN 5. So just need to check in the enabled. Then for the interface, we need to select the VLAN 5. Okay. Next is verify ES and 802.1x defaults. So from the security, need to check the AES, or Advanced Encryption Standard, then also the authentication key management for 802.1x. Need to enable this. So this is used for enterprise networks. We also need to configure the radio servers, also from the security, and then the AAA servers. Need to type in the IP address So this is a drop-down menu. We already configured the server, the SNMP server and radio server. So need to just select this IP address of our server. So verify that the new WLAN is available. So from the WLANs, we now see that we have this WLAN, company name, WLAN ID of 5, it's enabled WPA2, but we use the 802.1x authentication method. Also have the packet tracer for that. So let's have a review. Okay, let's go back from here. So configure a basic WLAN on WLC. You just need to log into the wireless LAN controller and then verify. So from the advanced settings, we need to verify that is from the okay. So first one is we need to create a wireless local area network. Okay. Then enable the WLAN, select the interface, but in real life we need to create an interface. Okay. Secure the WLAN. So we just need to configure the security for the WLAN and also for verification. Now for the WPA2 enterprise WLAN, so it's a little bit complex. So first one is we need to connect with the server from the wireless LAN controller. So in this example, we use the PCA, so it serves as our radius SNMP server. So we configure our wireless local area network. So to connect with SNMP, I use the create drop messages, and we use type in the IP address of the IP address of SNMP server. Okay. Okay, this is the IP address. Is that the IP address of SNMP server? Let's see, wait. PCA 172.16. Management network. Okay, 172. This is the IP address for SNMP. We also need to configure the radio server information. Okay. Type in the IP address for the server on some of configurations. We also need to create an interface. These are the steps for creating. Then after creating, we need to configure the scope for the IP addresses or DHCP scope. Then also we need to configure the security for our enterprise wireless local area network. So troubleshoot WLAN issues. I thought that we now have the module practice. Yes. So troubleshooting approaches. We have 6 main steps shown in the for troubleshooting. So first one is we need to identify the problem. Second step is troubleshooting. It's just a process of solving the problem or any problem. So it also includes the WLAN issues. Okay. So step 1 is we need to identify the problem. Step 2 is establish a theory of probable cause. So just theorizing the causes from the user. So we just need to talk to the user and also identify the problem. So test the theory to determine the cause. So after that, after we determine the cause, we need to establish a plan of action to resolve the problem and implement the solution. We also need to verify, for step 5 is verify full system functionality and implement preventive measures. And the last one is document findings, actions, and outcomes. This is very important for future reference. So for wireless client not connecting, so these are the troubleshooting steps. There is no connectivity. So for example is to verify that the PC has received an IP address via DHCP or is configured with a static IP address. So if PC is operational but the wireless connection is performing poorly, check the following. So we need to check if how far is the PC from the access point. So is the PC out of the planned coverage area? So if the PC is out of coverage, so obviously it will not be connected to our access points or wireless router. Now for troubleshooting when the network is slow, to optimize and increase the bandwidth of 802.11 dual band routers in APC there. So dual band routers, so it operates in both 2.4 GHz and 5 GHz. So first one is upgrade your wireless clients. So older versions here that operates with devices can slow the entire WLAN. So our wireless device should support the same highest acceptable standard. You can also split the traffic. So for example here, so this laptop connects to this WLAN, so which operates with 2.4 GHz. Then this device is connected to this WLAN, so it's two WLAN for configured in this access point, and then they can connect with it operating with 5 GHz band. So we use 2.5 GHz network for basic internet tasks such as web browsing, email, and downloads, and we use the 5 GHz bands for streaming multimedia. So updating firmware. Our firmware releases may contain fixes for common problems supported by customers as well as security vulnerabilities. We just need to update our firmware if firmware is available for your device. So the path tracer. So we have this path tracer from our YouTube channel. Let's see. For example, let's see. So this is my channel. We now have 53 videos, 6 subscribers. So from the playlist, we have the bridging course. So we have the path tracers here. We have the course view. We're now on 12. It's module 13. The path tracers. We now have 23. Okay. So for the module practice summary, we have the path tracer, so WLAN configuration. So I think we don't have the guide. Okay, what did I learn in this module? So we learn how to configure. So in this module. So module quiz, WLAN configuration. So I need to perfect this. So a user is configuring a wireless access point and wants to prevent any neighbors from discovering the network. So what action does the user need to take? Just need to disable the SSID name broadcast. Okay, so we cannot see the SSID name. So when a wireless network in a small office is being set up, each type of IP addressing is typically on the network device. So it's the private IP address. So a user has just purchased a generic home router and would like to secure it. What should be done to help secure the wireless home router? I just need to change the default administrator password. So it is because it's set by default as the admin password and admin for username. So which protocol can be used by a company to monitor devices such as wireless LAN controller? So we have the SNMP. So we use the SNMP protocol for log messages. Okay. Monitor the traffic from the WLAN. So when configuring the Cisco wireless LAN controller for WPA2 Enterprise WLAN, so what has to be created on the wireless LAN controller before creating the new WLAN? So we need to create a VLAN. So what is DHCP scope as it relates to a WLAN configured on the WLC controller? It's just a pool of IP address for WLAN clients. So why would a technician configure a passphrase for a WLAN on a wireless router? So we just need for the authentication for wireless client. So a customer installs a wireless access point at home in the closet next to kitchen. So the customer mentions that the wireless communication performance seems degraded when the cordless phone or microwave oven is in use. So what is the possible reason for this degradation? So it's because the wireless signal is in the same radio frequency range as the household devices are in. So there is an interference between devices. So what functionality is required on routers to provide remote workers with VoIP and video conferencing capabilities? We have the quality of service. So we set up these functions. So a wireless router is displaying the IP address of 192.168.0.1. What could this mean? Okay. So the wireless router still has the factory default IP address. So we need to change this to a private address, though it's a private address. So a laptop cannot connect to a wireless access point. Which two troubleshooting steps should be taken first? So we need to ensure that the wireless NIC is enabled, the network interface card. So we also need to ensure that the wireless SSD is chosen. So in setting up the small office network, the network administrator decides to assign private IP addresses dynamically to workstations and mobile devices. So which feature must be enabled on company router in order for office devices to access the internet? So we need the NAT, so for the conversion of our private IP addresses to more public routable IP address. So what is the difference between autonomous APs that operate in home environment and controller-based APs that operate in corporate environment? So I have the controller-based APs or lightweight APs. So it can be automatically configured and managed by our WLC. So which of the WLC tab would the network administrator typically use to see a summary view of the most heavily used WLANs, including the number of clients using a particular WLAN? So I have the monitor tab. So users on this 11N network are complaining of slow speeds. So the network administrator checks the AP and verifies it is operating properly. What can be done to improve the wireless performance in the network? Change that. So need to split the wireless traffic of 2.4 and 5 GHz band. Have correct answers. So the next modules will be more about routing. So it's not part of the bridging course. We are done now on the modules from the bridging course. Now we have the module 14 for the routing concepts, 15 for IP static routing, and 16. So the last module is troubleshoot static and default routes. So now 3 modules remaining. That's it.